Good day. So in this video, I want to introduce you to the advanced statistical graphs. And at this level, we have three advanced statistical graphs. The cumulative frequency curve, which is the most popular and also one of the easier ones, and you'll see why in a little while. We have the frequency polygon as well, and the histogram, and those two related somewhat. So let's see how to do a cumulative frequency curve. So a cumulative frequency curve, and again, if you recall, for statistics, I already tell you when we're doing a graph for statistics, it'll be L-shaped. We don't have any negative components, right? So we're expecting an L-shaped graph. And on my graph, I need to have the axes labeled. So this tells me what's going on the axes, and then it'll help me to plot the points on those axes later on. So on a cumulative frequency curve, and it is a curve, we plot any cumulative frequency on the y-axis. So on the vertical axis, we have cumulative frequency, and on the x-axis, well, they interchange sometimes, but you can have either the upper class limits or upper class boundary. So it's the upper limit or upper boundary of that particular interval. If we're using the limits, we're using the solid numbers. If we're using the boundary, to be the decimal. But this will have some specific name. It could be age, it could be weight, it could be height. The example we're going to use is going to be marks. So that tells me what going where. So I need to get cumulative frequency on the y-axis and the upper limits or boundaries. We're going to use the limits for this example just to explain. And the nice thing about this graph, what makes it easy, the graph have the same shape all the time. So once I do this correctly, I'll know because the graph going to be looking a certain way. So the way the graph is looking, I'm just doing a quick sketch here. The graph is have a slight S shape to it. So again, it's just a little sketch, but the graph always looks something like that. The ogive is what they call the name of this shape. That's not something they already ask, but almost every time I do my cumulative frequency curve, it's going to have that slight S shape to it. So if I don't have that, or it belly out somewhere, that's the points I need to double check because I know something off. So let's see how to actually get the cumulative frequency, which is different from regular frequency. So we're going to use this example here. The frequency distribution of the maths marks obtained by 80 students. So that's the total frequency there. We're using 80 students, and I take the marks. Instead of writing out all the marks though, I have it as a frequency distribution on my frequency table here, and you realize nobody scored less than 15. The lowest mark was between 16 to 20, and we jumping in fives if you notice as well. That would be the class width and some of the other stuff we did before. So what we need is, on the x-axis, we need the upper class limits or boundaries. We're going to use the limits for this question, like I said. So where the upper class limits coming out from? So the upper class limits come out from the intervals. So these are the intervals here, and I would already tell you, and you would have seen before, that each interval have a bigger number and a smaller number. They call the smaller number the lower limit, and the bigger number we call the upper limit. So for this one, these are the upper limits here. So those are where my x values coming out from. My y values, according to what I need to draw, is the cumulative frequency, which is different from the frequency. So number of candidates here, this is really frequency. I don't want regular frequency, I want cumulative frequency, and we're going to see how to get the cumulative frequency. But this is how my y value is going to look, or where my y value is coming out from. And since I'm doing a graph, the only way I could draw a graph is if I have points, and a point is always in the form x comma y. We would have seen that earlier. So I have to take this x number, pair it off with the corresponding y number, and have a point. So in fact, I already have my first point. 20 and 7 going to be the first point on my graph, because I'm pairing up the x and y for those corresponding values there. But let me see how we get the cumulative frequency. So cumulative frequency means we're building up to a point, everything building one on top of the next. So how we get those values is, we start off with this same upper class limit or boundary. So we want to know how many people using the upper class limit or boundary. We're using limits in this question. How many people scored 20 and under on this test? 7 people scored 20 and under, meaning they score from 0 to 20. And they already have the 7 there from there. And then we keep going. How many people are using the inequality notation scored 25 and under on the test? Now, keep in mind, 12 score between 21 to 25, but I want how much people score under 25 in total, meaning from 0 to 25. So all of these people score from 0 to 25. 7 and 12 scored under 25. So 7 plus 12, 19. and my next point on the table will be 25.19. You could leave it for the end, or you could fill it in as you go along one time, and then we keep going like that. How many people scored less than 30? So now all of these people scored less than 30. Now instead of adding 16 at 12 at 7, I already know up to this point totaling 19. So all I'm really doing is adding this number to this number, 16 at 19, to get 35. And my next point will be 30, 35 to plot on my graph. And again, I keep going until I reach. And last one I'm doing, and then I want you to try some for yourself. So how much people score less than 35? So again, all of this already adding up to 35. So I have 19 new. So I'm going to add 35 and 19. So 19 and 35. Or in other words, I'm adding up all of these. That'll take a little longer, but you can still add up all of them. But this way will be shorter. I get in 54. So my next point will be 35, 54 to plot on my graph. So what I want you to do next is pause the video here. And you see if you could finish out this and come up with the rest of the numbers. And then when you unpause the video, you'll see if you got it correct, right? So just double check that. You could pause the video, try it a little bit for yourself, and see if you get it. So I'm going to continue. So less than 40, again 15 at 54, I'm going to get 69. So in other words, all of these people adding up, and my point will be 40, 69. And then I keep going. Less than 45, it will be 8 plus the last number I get, 8 at 69, 77. So my point going to be 45, 77. Because I'm pairing up the x and the y value. Each graph going to have a different pairing, by the way. This is the pairing for the cumulative frequency curve. And the last one, and I'll know if I'm correct or not, that's the nice thing about this as well. Less than 50 means everybody had to score 50 and under on the test. So by this point, if my numbers didn't add up to 80, that means I make a mistake somewhere along the way, and I need to double check all my calculations to see where I made that mistake, but I know it had to add up to 80. Now that I have all my points, I could actually sketch the graph now, or draw the graph. So first part, copy and complete the table, and usually they don't make you do the whole table. They might just be missing a few numbers and you fill it in. They give me a scale to draw the graph, right? So using a scale of 2 centimeters to represent 5 marks on the x-axis and 2 to represent 10 students on the y-axis, vertical axis, draw your curve. So I already sketch up a graph here. So on the x-axis, if you're watching, use a scale of 2 centimeters. This is the x-axis, the horizontal axis. Use a scale of 2 centimeters to represent 5. Terrible. So that means every 2, but you realize that I'm going to start the horizontal at 50, not at 0, because since we had nothing from 0 to 16, they want me to start at 15 and move in 5. So every 2 centimeters, which is 10 tiny blocks, are jumping in 5s. That's what the scale tells me, and that's why the scale is important, because if I don't put the proper scale, my graph will look different from everybody else, so I mightn't get the desired effect. So I check in every 2 centimeters or 10 tiny blocks and increasing by 5. So this going up to 20, and next 2 centimeters, 25, 30. How much am I carrying the scale up to though? So if we go back to the table, the x values went up to 50 marks. So by the way, this here telling me the marks, the upper class limits are the marks. So this is going to be 35, 40, 45. So we're carrying this up to 50. That's where we're carrying this up. And then we're doing the same thing for the y-axis now. So the y-axis, 2 centimeters is 10. So it's the same spacing, but now I'm spacing it out in 10. Starting at 0, every 2 centimeters are jumping by 10, 20. And how far carrying this up to? My biggest y value, or cumulative frequency value, which is the total frequency, is 80. So I'm going up to 80. So 30, 40, 50, 60, 70, 80. I didn't need the whole graph, if you notice. And this is my y-axis, and that's where the cumulative frequency gonna go. My cumulative frequency gonna go here. My light starting to fade this before you notice it. Let me see if you can finish off the video. So what next we're gonna look at now is we actually need to plot the points. So I'm gonna plot a few, and you could try it yourself. Again, if you don't have graph paper, you could just drop a scale just to get an idea of what it will look like and see if you get it. So the first point is going to be 27. So looking at my graph here, 27 means x is 20 on my x-axis, y is 1, 2, 3, 4, 5, 6, 7. So where both of these meets, I put in an x to mark the spot, or a bullseye, a dot with a circle around it. And then I keep going. My next point is 25, 19. I find x is 25, y is 19, and where both of them meet up. Keep going. 30, 35 is my next point. So x is 30, y is 35, 31, 32, 33, 34, 35. And we keep going like that. I keep plotting the points, and eventually, when I plot out all my points, I'm going to get something like this. And you can see the slight S shape already. Once I have all my points, I'm going to connect the dots. So I'm just going to connect the dots freehand, and it must be a curve. I can't use a ruler, because if I use a ruler, it will be too blocky, and this must be a curve, and it will actually take out a mark from what I understand if it doesn't look like a curve, and I carry it back to 0. And you're seeing that slight S shape where it rises from the bottom and comes up to the top. So that's what we call a cumulative frequency curve, and if it had belly out anywhere, that means I make a mistake at one of those points. So that's what the graph going to look like when we draw it, but obviously they can ask you some different things on the graph, and just a couple things I want to look at quickly. So using the cumulative frequency curve, deal with the median. We would have seen median before. Median means the middle, but in terms of the graph, we still want the middle, but we want a point basically on the graph, a specific location on the graph. So the median is the corresponding x value to half of the total frequency. So the total frequency in this question was 80. So half of 80 would be 80 divided by 2, 40. So at the 40 mark, I'm going to take my ruler and draw a straight line across. I can't use my ruler too well right now because I'm holding the phone. So I'm drawing a straight line across here with my ruler. And the moment I hit this here, I extend that line down. And I read with a ruler, obviously. Sorry about that. So that point there going to be the median. So I read that point off my graph, and that point will be the median. But that's how we find the median mark. Half the total frequency. So if your frequency was 100, half 100 will be 50. At the 50 mark, I draw a line across. The minute it hit the graph, draw it down and read that value off your graph. What does this value mean though, if you could see it? So it is 3 tiny blocks after 30. Does that mean it's 33? Because if it was 33, that means 34, 35. But here is not 35. Here is 35. So do assume, just like in this scale, everyone was 1, but in this one, everyone is not 1. Because if you watch 20, 21, 22, 23, 24, 25, it's twice as far away. So we had 10 blocks making up 5 units. So that means each block will be 5 over 10, 0.5 or a half. So this is really moving in halves. So be careful when you're reading off your scales. So this is really 30 and a half, 31, 31 and a half, 32, 32 and a half, 33, 33 and a half, 34, 34 and a half, 35. So the median here, based on my graph, because depending on how you draw your graph, it'll be close to this. I get 31.5 marks. That was the median mark or the middle mark on the test. Now they would ask the median ever so often. The graph is the main thing though. What they could also ask is the quartiles. So quartiles just mean I'm breaking up my graph into quarters. The median is the middle or the halfway mark, but the lower quartile will be a quarter the total frequency, the upper quartile 3/4. So if we were to use this example with quartiles, a quarter 80, the lower quartile would be at 20. I draw my line across. The minute it hits, I draw down. My upper quartile would be 3/4 of 80, which would have been 60. I draw my line across. The minute it hit the graph, it go down. But that's how we get the quartiles, and you'll see that a little more because it even comes in the multiple choice questions now. But that's when we break up the graph into quarters. We could call it quartiles, with the median being the middle or the halfway point, but everything else will be in quarters. So this is really 2 quarters by the way, right? Because everything moving up in quarters. Last thing I want to look at before we finish off is they usually ask a probability piece here. What's the probability that a student chosen at random has a mark greater than 40? So I want to pick a student from the class because that's what they want. They want me to pick a student from the class that has a mark greater than 40. How much students they have in the class? So my bottom number already going to be 80. And greater than 40 means we're not including 40. That's the top part now. We're looking at numbers greater than 40. So we're looking at 41 and up. So based on my table, because I have no choice but to use the table now, it have no raw data. So this is the part that is 41 and up, meaning 41 to 50. And these are the people that scored 41 to 50. So it will be 8 plus 3. In other words, 11 people out of the 80 scored greater than 40 on the test. So that's what it will look like. And this is the example for cumulative frequency before we try one ourselves.